If you've ever wondered what's going on in your brain when you're choosing what you want for lunch, look no further. Researchers from Washington University School of Medicine in St. Louis recently published a paper in the journal Nature, where they used a neat experimental trick to show what was happening in the brains of monkeys as they chose which tasty beverage they wanted to drink. I'm Eva Higginbotham, and I spoke with lead scientist on the project, Camillo Padua-Schioppa, about how it works.
The paper is about choices, or as we call them, economic choices. And a simple example would be the one in which you are in a restaurant, look at the menu, and there are multiple options. Let's say there is two options, maybe pasta and maybe soup, and you have to make a choice. And the general question for us and for the field I'm in is to understand how the brain generates this kind of decisions. The idea that has been around for a long time is that we do so by assigning values. That is, we assign a value to the pasta and then a value to the soup, and then we compare these values, and that's the decision process. We and others show that neurons in the brain represent the values of different options when people or animals choose between them.
When we say assigning a value to something, what does that actually mean? Is it like saying, oh, for pasta, it's worth 10 points and for soup, it's worth 5 points?
Something like that. Now, it's subjective, the value. So the value that I assign to the pasta, especially being Italian, may not be the same as you assign to the pasta. And so the value is intrinsically subjective. And in fact, it also depends on the context. So the value I assign to pasta early in the morning is not the same as that I assign it, at lunchtime. So it is like points, but it is context and subject dependent.
And so how do you get then from a value to neurons in the brain? And where are these neurons?
So the orbitofrontal cortex is part of the frontal lobe, and it is the part of frontal lobe that is just above the eyes. That these neurons encode value means that there is a linear relationship between the activity of, let's say, one neuron and the value of whatever is offered to the subject.
So that means that if I think pasta is of a higher value, there are some neurons in my brain that are going to fire more and have higher activity because of that, as opposed to the soup, which has lower value and so has less activity in some other neurons. Is that right?
In essence, yes. So there are some neurons that represent the value of the pasta and other neurons that represent the value of the soup. Now, the value depends not just on whether it's pasta or soup. It also depends, for example, how much there is of it. And so these are two different groups of neurons. They both activate depending on how much pasta and how much soup is presented to me as an option. And then the decision is made by comparing essentially the activity of these two groups of neurons.
So what were you trying to understand in this study?
So to say that a neuron encodes value is good, but it does not necessarily imply that that neuron causes the choice. And so what we did in this study is to show that if we artifactually or artificially increase the activity of these neurons, we could bias decisions in a predictable direction.
How do you increase the activity of neurons?
We do so by injecting electric current. So we put tiny electrode in the brain in this area. And incidentally, that's not painful to the monkeys because there are no pain receptors in the brain. And the effect of injecting current is essentially to increase the activity of neurons around the electrode. So we had to design the experiment in a particular way to make it so that we would essentially increase the value of one of the two options more than we increase the value of the other one.
And this was done in monkeys, right? So what were the monkeys choosing between?
Right. They were not choosing between pasta and soup. They were choosing between different beverages, different juices. So one particular session, maybe they were choosing between, let's say, grape juice and apple juice. In other sessions, we had lemonade, peppermint tea, and, maybe a dozen different juices.
So you offered some monkeys some different drinks, some different juices, and they had to choose between them. And you managed to artificially bias their decision. How did you do that?
Yeah, so that's the trick, and it's slightly technical. So I'll try to explain it like this. So the activity of these neurons is in a linear relationship with the value offered. Now, the value or the quantity that we offer on any given trials varies. So if the animal is choosing one session between grape juice and apple juice, and then we look at neurons that encode the value of grape juice, the quantity of grape juice we offer may be, 1 drop in one trial, 3 drops on the other trial, and so on. And there is a range of values that we use in a particular session. So maybe the range of values for grape juice is between, let's say, 0 drops and 3 drops. So that's called the range. And the same, there is a range for apple juice, which could be larger. It could be, for example, between 0 and 10 drops. Now, there is a property that these neurons have called range adaptation, which means that essentially the response of the neurons varies not only for the quantity that we offer on any given trial, but also for the range that we use in that particular session. So another way to say this is that if we present 1 drop of grape juice in a session where the grape juice is offered between 0 and 3 drops, the activity is a certain activity, let's say 10 spikes per second. If in a different session, grape juice is offered between 0 drop and maybe 6 drops, then the activity is lower than that because of an adaptation.
I see. So if they're used to having between 1 and 3 drops of grape juice, then when you give them 1, that's kind of like, that's pretty good. Whereas if they're used to getting between 1 and 6 drops of grape juice and then you only give them 1, well, that's not as good because they could be getting 6.
Perfect, exactly. What that means is that when we put the electrode and inject a little bit of current, in essence, we are increasing the firing rate of these neurons. And that increase of firing rate is equivalent to increasing the value that we offer to the monkey. But the increase in value depends on the response of the neuron, which means it essentially depends on the range of values that are available in that session. And so what we did in the experiment is to set the 2 ranges for the 2 options, so for grape juice and for apple juice, in a different way. So one of the 2 was large and the other was small. And by increasing the firing rate of both groups of neurons, effectively we increase both values, but one of the 2 values increased more. The value of the juice that was offered in the larger range was increased more than the value of the juice offered in the small range. And so the overall effect of the stimulation was to, yes, increase both values, but increase one more and therefore bias choices in the direction of that juice.
So it increases the value of, say, the apple juice more because you could be getting between 1 and 10 drops of apple juice versus 1 and 3 drops of grape juice. You apply the stimulation, the electric current. Although both grape and apple juice increased, the apple juice, because the range was bigger, had the potential to increase even more than the grape juice. And so it did. And so you bias towards apple. Is that right?
That is right.
So what did you find?
So we found that by doing this, by letting the animal choose between different juices, varying the amounts and setting the ranges unequal, we would inject current on, let's say, half of the trials. Randomly, the animal didn't know when we were injecting current. And we observed that on trials in which we injected the current, the animal was, other things equal, more likely to choose, let's say, apple juice, compared to trials where we did not inject current. And if we, in a different session, maybe subsequent session, left everything the same, so the electron in the same position, still the 2 same juices, but now changed the ranges. So maybe now the range of grape juice was large and the range of apple juice was small. In that case, injecting current would bias choices in favor of the grape juice.
What does that then really tell us about how these monkeys were making the decisions of which juice to take?
What that shows us is that the activity of these neurons is causally related to the choice. That means that there is a causal chain between the firing rate of these neurons and the decision, the choice the animal eventually makes and shows us. So causality is really what we were able to nail in this study that had not been done before.